How is everybody? Good. Any questions? Any comments, concerns? I don't think there's any housekeeping to take care of, so. Yes, sir. It broke. Yeah. I dropped it, and like the Tauntaun in the second movie, its guts got all over the place. And unfortunately was too small for me to crawl into the fetal position and weep. So, yeah. I broke my lightsaber. I think it's repairable, but I haven't had time. So the light had stopped working, and I had meant to take it apart anyway. So, you know. But yeah, yeah, you'll just have to have me au naturel. So, yes, question.
When are we going to get information on this?
That's next week, right?
I think the midterm.
Yeah. Oh, we can talk about the midterm now if you like. So, information about the midterm. You may want to be paying attention. Coverage up to and including the topic that we're currently doing. So we're going to be finishing pointers by the time the midterm comes, and you will be, tested on pointers. The form of the test, you will be required to write C programs in a time-limited environment. You will require the use of your own laptop/tablet/computing device in order to perform the test. So whatever you've been coding on so far, as long as it's not a desktop, that's what you'll need during the test. We have booked a room with outlets, so you don't have to worry about running out of charge. It will be absolutely paramount that you have a laptop set up where you can, write and, debug and all the rest of it, your C programs. I know that seems kind of silly because you've done 2 assignments now and everybody in the room should be able to work on C files, yet somehow there's always a couple people who get to the midterm and they're like, I don't know what am I supposed to do? And it's like, well, how have you been doing the assignments so far? And it's like they haven't been or something, I don't know. But yeah, so you need to be able to program in C. That means you need to have your C programming utilities on your laptop for the test. The test will be collected via the Git repos in the same way that the test, in the same way that the assignments have been. No big changes or surprises there. All right? The same way you've been submitting things up to now is the same way that you will be submitting things now on the test. The test is 1 hour and 30 minutes in duration. It's an hour and a half. I was thinking 1.5 hours, and I said 1 hour 50 minutes, but it's not 50 minutes. It's 30 minutes. Yeah. That's about the long and the short of it. Any questions? Yeah.
Will there be questions on theory and everything that we're learning in lecture, or is it just complication?
Well, I mean, in theory, the theory that you were learning in lecture is directly applicable to the programming, so I don't think the lectures were completely useless. If you're asking me whether or not I'm going to quiz you on the history stuff that I've been talking about, no, I'm not going to put any multiple choice or anything like that on the test. It's just programming. Yes?
What do you recommend we do to practice?
Program.
Okay.
Yeah, practice programming.
Any sites or anything like that specifically?
there are a couple of sites. Code Academy is pretty good. They've got some problems. There's Lead Code is a bit of a meme, but they do have some good problems. You know, like not like the hard problems, but like the easy medium problems on Lead Code, I would actually say are easy and medium. Like I roughly agree with their difficulty ratings, if that makes sense. I won't ask like a hard level Lead Code problem because they require pretty advanced knowledge. Obviously, the programming you should be doing is in C. It's actually like completely. It's also completely valid. Like, if you have some programs that you wrote last year for your godforsaken Python course, doing a C implementation of those algorithms, as long as it's not something too complicated involving like dictionaries or other stuff that obviously C doesn't natively support, you know, that's also perfectly valid practice, you know. But like in general, overcome your fear of compiler errors is another big one. Does that make sense?
Yeah.
Yeah.
One follow-up.
Oh, there should be some practice problems posted on Avenue as well. Yeah. Follow up?
How many questions are going to be on the test, or how's it going to be structured? Is it just going to be one problem that we work through, or is it going to be something?
No. It will be a set of problems, which I'm not going to reveal the exact number, but no, I won't give you like one problem, because like if you fail to get it to compile, you get 0 on the test, and that's a bit mean. Yeah. Now, whether if I give you a whole bunch of problems and you still fail to get anything to compile and get 0 on the test, it's, there you go. But the mechanism of evaluation for the test will also be the same as the mechanism for evaluation of the assignments. So, solutions containing syntax errors are not worth any marks. We are not going to listen to people saying, oh, but you should be marking this subjectively because it's a test. It's like, no, we should be marking it fairly because it's a test. Question?
Compared to like the assignment questions, what's the difficulty like?
Not going to be as difficult as assignment questions. The assignment questions are designed to take you, maybe an hour. I don't know. It varies widely based on the assignment question. But yeah, no, I actually do have a methodology for putting a test together. What I do is I devise a sequence of questions. I then have the TAs write it, right? And normally I'm comfortable if the TAs finish the test reasonably, get the questions mostly right, shall we say. I'm happy if they finish it in like 1/4 to 1/3 the time you guys have. That's like the general rule for math tests is like one of the instructors, either the professor or maybe the TA should be able to finish the thing in 1/4 the amount of time that the students have for it. So yeah, there is a methodology. This isn't my first rodeo. Question?
What resources do we have access to? Like, is it multi-internet, that kind of stuff?
Oh, no. You don't have, you can't Google things, right? Your permitted memory aids will be one double-sided crib sheet, right? Everything else has to be like IDE tools if you want help in that respect, right? Make sense? So, yes.
So, I don't know if a lot of other people have the same issue, but like sometimes the commit doesn't commit, if that makes any sense. It says that you have like a certain issue which doesn't exist, and it doesn't let you commit. It's like, for example, if that happened on the exam, is there like an alternate way to submit, or like can I drop the file in like the main area? It's like I'm able to for example, a question I can drop it in the section where we have to do like A1, A2, A3, so like the place where it's like assignment, but I can't get them into files. I still haven't figured that out. I manually do it through the interface.
So the emergency backup submission mechanism would be to email me a zip file. However, now that I've said that, I'm sure I'm going to get like 50 zip files. So my expectation is that if you have difficulty with getting the Git submitted through Git, that you will inform a TA during the test that you're having this problem, and they will give you explicit, the TA or myself, we will give you explicit permission during the test to submit through an alternate mechanism, and we'll write your name down on a list so that we know who was permitted and who was not. Because if we're allowed, because the test is being submitted electronically, we also have to keep track of who's actually in the room. Because if you're not in the room, you don't get any marks, right? This is not a remote test. It will be an invigilated test that you are required to come to in person. And if you don't, you will get nothing. You will lose. Good day, sir. Any questions? Yes.
So for the internet, we can obviously access like the Pascal server for operation, okay?
Yeah, like you can, if you've been programming on Pascal, obviously you can use Pascal for the test. Submission through Git also requires internet. So, it's not like we're gonna go around screaming at people that they've got their Wi-Fi on, right? But we are going to be walking the room, keeping an eye on people's computer screens from the back, making sure they're not accessing anything they're not supposed to. All right, so this is like manual invigilation. Okay? Questions?
Did you mention something about a double-sided cheat sheet?
Yes.
How does that work?
You take a single piece of printer paper, right? You write anything you want on it, you get to take that into the test with you. Yes?
So because we're submitting the same file that we used to push to the GitLab repository, right? So would it be cheating to go look at our past assignments that are in the same file and see look at the past code we've made ourselves?
They won't help you.
Okay.
Yeah. I'm not going to ask you variants on assignment questions. None of your assignment code will be useful to you in any way whatsoever.
Like if we wanted syntax, if we forgot how to.
Yeah, no. If you want to look at that stuff during the test, put it on your cheat sheet.
Okay.
We're going to be highly suspicious of people who are clicking around to things, if that makes sense. Question?
This might be a dumb question, but I'm assuming because we're not allowed to use that stuff, we're not going to be there's not going to be any functions required that aren't popping up in our assignments and stuff.
I won't expect you to use any standard libraries that are that haven't been talked about, if that's your question.
Yeah. But should we study the header files math or I don't know.
It's always good to know what's in them, because you can save yourself time on a test by knowing what's in them, right? With respect to the use of the standard library functions, you have your full skill cap available, if that makes sense. So if you know how to use the string library, then you are permitted to use the string library, even though we haven't covered it, right? However, my timing for the test will be on the assumption that you only know what we've covered in the lecture so far, if that makes sense. There is such a thing as a stupid question, but that wasn't a stupid question. Questions?
Yeah, so you know how in the assignment you get a template with a function prototypes?
Yeah, you'll have the templates with the function prototypes given to you. You don't have to, I'm trying to test your C programming, not, how long it takes you to make folders in a Git repo, right? However, the unzip procedure, that's on you. Question?
Okay, are we going to be provided test cases on the test, or are we going to need to make them our own?
I'll give you a few, but in general, you should also be able to make your own, you know.
Out of
Yes.
curiosity, so like if we're allowed to put a piece of paper, right, front and back. So is it possible? But that's probably not
You can't put sticky notes on it.
No, not sticky notes.
Okay.
Is it possible? Is it possible to have it like on a Word doc? So like if
Oh,
we
like
it's
typed up so that
Yeah.
the print is super tiny?
No,
Yeah.
no, not to, like so like for example, like if I had a certain case, instead of like just copying it from the paper, I could just copy paste it from Word. For example, like if
Oh, you want an actual like electronic Word file?
like instead of the 2 pages.
No.
is it possible? Okay.
No. Has to be
Word.
pen and paper. Yeah. You can use a document generator to type up your cheat sheet if you wish and then print it out. But print it out is the operative term. And there is no code that you can put on it that you'll be able to copy paste in that direct fashion unless it's like printing an array and you haven't like if you don't know how to print an array by now, you know. Any other questions? I would like to just give 2 brief words on the subject of crib sheets before we move on with our lecture today. While the temptation is great to use someone else's crib sheet or to somehow collectively come up with the crib sheet so that, you know, half the people in the room are all using the same crib sheet, by doing that you are throwing away some of the most valuable studying that you can do for the test. Creating your own crib sheet requires a process of reading through the material that we've covered so far and summarizing it in your own words, in your own way, on your own paper. This is extremely effective studying, and it breaks my heart every time I see people using other people's crib sheets, because it's like, you know, and people wonder why they get bad grades, you know? But anyway, so there we go. Cool. Oh, and I'm pretty sure my wife went into early labor this morning, so. Yeah. Don't clap yet. Clap when it's over. How familiar are you guys with like the whole biological process? I know, second time I've made that joke, right? But no, but like it's really quite interesting actually, right? Because like, I mean, should I say it or shouldn't I? Do you guys want the digression? Okay, we'll do the digression. All right, biology lesson. So the fetus exists inside of the amniotic sac, which is a sac of fluid, right? This sac of fluid can rupture at any point, right? Which is what's known as the water breaking. At that point, you have 24 hours, or you have 48 hours, because that opens that creates the risk of infection, right? So past that point, it must be 48 hours, and they will medically induce you if it's not going fast enough, right? With our first, that actually was what happened. Is just randomly in the morning, my wife's water broke, and that started things off. This time, that didn't happen, right? So, not yet anyway. It normally happens at some point, although it is possible to be born still inside the amniotic fluid sac. They call these mermaid babies, and it's very strange. But anyway, so the whole process is mediated by the cervix, which is essentially a great big sphincter, not dissimilar to the one that closes your stomach at the top, right? Before the woman enters labor, there's what's called a mucus plug, which is disgusting because, mucus. Basically a great big snot ball is keeping the uterus closed, right? Over the course of things getting towards labor, this thing either, it dissolves somehow or is removed in some way, right? This allows the sphincter to begin dilating. The dilation of the sphincter produces the hormone oxytocin, which begins the process of what's called true labor, or the processes of the contraction of the uterus, which sends the kid out, right? So once that process starts, it can actually take a number of days. So that's why I'm here now and not at home, is because we're sort of in the early phases, and it might be today, it might be 2 days from now, it might be 1 day from now, but it's definitely probably going to be this week, early this week as well. But so that's and any questions about anatomy? No? Okay. All right, simmer down. Let's talk about programming and junk, or else we'll never get to the test if we don't cover this stuff. So, I see the plan now. Anyway, so pointers. Last time we talked about pointers, we talked primarily about setting up the data types, right? Understanding, of course, that pointers do have their own distinct data types, right? You have to declare them with the star, that makes it a pointer, right? We have talked about the address of operator ampersand. You put a variable in, you receive back the memory address at which that variable is stored. The inverse operation of this is pointer dereferencing. Also using the asterisk character, somewhat confusingly. Again, if I were Dennis Ritchie, I would have picked a different one, but I'm not. I completely lack that kind of talent. So, essentially, the dereferencing operator, which is probably the one that will give you the most trouble, requires a memory address and extracts the value stored at that memory address. If this is a double pointer situation, the value that's being extracted may be another memory address, right? So if we have this small program, y is 5, int star y pointer is equal to the address of y, and then we print both of them. The pointer's value is this big long hexadecimal thing, and the value pointed to is 5. Notice that we are dereferencing y to get to that value. Question?
How does the dereferencing operator know how long if it's an int or a long int?
It's attached to the typing information. That's an excellent question, thank you. The question is, how does the dereferencing operator know how many bytes to read out of memory? Whether it's an int or a long int or a character or what have you. The y pointer variable itself, basically there's a table, right? There's another table that's being kept by the compiler, actually. The table doesn't actually matter with all of this comes out in compilation. By the time it's actually compiled, it will be pointer dereferencing that with some kind of fixed specific bit width to be read in assembly code. But for the purposes of the compiler keeps a symbol table where it keeps track of the data types associated with every variable. So pointer dereferencing accesses the typing table, sees what kind of pointer we're dealing with. In this case, it's an integer pointer, and therefore returns the number of bytes equal to the bit width of an integer. Make sense? If this was a float, it would read the number associated with the float. If it was a double, it would read the number associated with the double, etc., etc. Make sense? Good question. Any other questions? Yes?
And that would change like which like formatter you need to put in, right? Like the percents, whatever.
Here, you mean?
No, lower below that.
Yes,
If it was
certainly.
a float, you have to like percent F, right?
Precisely, yeah. Because the data that you, well, I mean, as a few of you have found out during assignments, you actually can interpret a float as an integer, you just get nonsense, right? But yeah, if it's a float, you put an F there. Yes. Any other questions? Okay, good. So, let's talk about seg faults. We've talked about seg faults a little bit, but dereferencing a pointer that points to memory outside of your program's allocated memory space causes a fatal runtime error called a segmentation fault. Seg faults are, you know, kind of like the #1 cause of C program crashes, if you want to put it that way. So this can happen a number of ways, right? If you're dereferencing an integer, like rather than an integer pointer, if in the previous example we were dereferencing 5 rather than dereferencing the memory address, this would mean that we were asking the operating system for the data stored at address 5. Address 5 is likely to be used by some of the computer's very first startup routines, shall we say. Or maybe not. Who the heck even knows what 5 is? All the operating system knows is that that's not an address that belongs to you, and therefore that would crash the program, right? Dereferencing a null pointer has the same effect, because null is just 0, so you're asking for the data at address 0, which doesn't belong to you, so snapshot goes the seg fault. This is most common with null pointers, but can also happen if you mess up pointer arithmetic. The seg fault is your friend. The seg fault is preventing you from doing dangerous things, like overwriting values that your operating system is using in memory, for example, right? So, without seg fault protection, your entire computer would be laid bare to any program running on it. And we don't want that. That's undesirable. Seg fault is your friend. It's kind of like, you know, if you're on trial for murder and the judge and the jury finds you guilty, and you actually did it, they are your friends because you should stop murdering people. Going to jail is the correct disincentive if you're a murderer. So it's kind of like that. Not that I'm likening producing seg faults to murder, but, you know. Anyway, so, yeah. So here's another program just demonstrating the fact that the address of and dereferencing operators are in fact inverse operations of each other. That is to say, one undoes the other. So if we have an integer a is 7, pointer to it, a pointer, we print a, we print the address of a, we print a pointer, we print dereference a pointer. We can see that a is 7, the address of a is this bad boy, a pointer is the same bad boy to the digit, and dereferencing a pointer gets you back to 7. Generating a memory address and dereferencing it leaves you where you started. So if you produce the memory address and then dereference it, there you go. Still yields 7. And if you do it the other way around, that actually yields a compiler error. So there you go. So, you know, because like, anybody care to guess why this last commented outline would result in compiler error? You have, yeah.
You're trying to dereference it into which.
Well, you can dereference integers.
But then you're gonna get a seg fault because you're trying to access something that you don't.
Yeah, but a seg fault isn't a compiler error. That happens at runtime. Yeah?
Because you're trying to address an address.
You're trying to address an address?
Yep.
Well, the dereferencing operation will produce the dereferencing operation will produce a value, not an address. So taking the address of an address is actually perfectly valid. That's how you get double pointers. Yes?
Does it have to do with the way it's like ordered, like just the way that you're addressing, if you're addressing a D or if you're addressing a dereference, does it just not make sense to modify?
It's essentially treating this thing like it's a literal, right? So this isn't a variable anymore. Once you've applied the dereferencing to it, it's being treated in the expression as if it were a literal, right? And you can't dereference literal, or you can't find the address of literals. They're not variables, right? So that's the reason that's a compiler error. Make sense? Question?
Can you just go over again what is a literal?
Any number like 3 or 7 or 2.7. Like any number that, like a number that appears in your code is a literal. Right? So when you have a string, like hello world, that's a string literal. Right? So once, like,
So like literals are assigned to variables?
you can assign literals to variables, yes. Basically what a literal, like, so when the compiler examines all of the symbols that are used inside of an expression, some of those need to be decoded and some of them are used directly, right? The ones that are being decoded are decoded into things that can be used directly, right? Those are variables. The decoding process is looking up the value of the variable. The things that don't need to be decoded are not decoded. The same operations are not applicable to them, shall we say. So once you have performed the dereferencing operation, it's no longer stored in a variable. So there's no concept of getting the address of the variable it's stored in. Does that make sense?
Yeah.
Good. Any other questions? Cool. So, so it can be easy to think of pointers as being entirely symbolic and forget that they too have concrete values in memory. Pointers may also be collected and organized into arrays, just like any other data type. A big phrase for pointers is just like any other data type, right? So, for example, we might have a constant character pointer array suit of size 4. Into that we put string literals, hearts, diamonds, clubs, and spades. Ordinarily, if we were to do this just with character arrays, we would want to produce a 2-dimensional character array. The problem with a 2-dimensional character array, these are all strings of different sizes. A 2-dimensional character array requires each row to be of the same length. This is the situation we're in here. So we have an array, right? This array is of fixed length because it's a static array, because the pointers are of invariant size, right? Despite the fact that the strings that they're pointing to are of variable size. They may be of any size, really, the array is still of constant size, which means that it's a static array, right? Which means that it can be declared up front. You don't have to use dynamic memory allocation. The dynamic memory allocation is this section here. Make sense? Question?
So what would happen if you got rid of constant in front of constant character array?
Oh, you'd just be able to also write to these pointers. So what constant does, right, it locks these pointers in place such that you can't overwrite their values. So they will always point to the same region of memory. That does not prevent you from performing write operations in the things they're pointing to. Right? So, you know, if you wanted to change it to say spakes instead of spades, you could follow the pointer to the reference and, you know, modify the character there to a K, and that would be a valid operation. But if you tried to point this point at a different string, that would be restricted and not allowed because of the const signifier.
And so what makes const different from static?
What makes const what?
Different from static.
Static, you still have write privileges, right? Const means you don't have write privileges. Yeah. Yeah, static just tells you, what static does is it holds the variable in heap memory rather than in stack memory, right? So that it's not deleted when the function terminates. And it preserves the link to that variable for future iterations of the function. That's why static variables kind of look like global variables in that they hold their values between executions. But they don't. Basically, a static variable is a global variable that doesn't have read permissions outside the function that it's declared in, right? Really, all of these minor variations on variables and like, you know, const variables and static variables and extern variables, it all comes down to two factors. Is it being stored in Is it being stored in stack or heap memory, right? And what kind of read-write permissions am I enabling? Make sense? Good. Question.
So if we were to access the first element of SU, we're just getting an address that points to hearts, right? Or are we getting hearts itself? Do we have to dereference it?
Yes. Suit at 0 would be a pointer to H. So if you have to dereference this to get H. Yeah. And because the square bracket operator gets transformed into pointer dereferencing with offset, you can, in this case, still use suit at 0, 0. Like square brace 0, square brace 0. That will still get you H in this scenario.
Is it just H or is it the entire word parts?
So C considers suit at 0 not dereferenced to be the string. The pointer to the array is the array as far as C is concerned. Does that make sense?
Makes sense.
Yeah.
So we're just accessing the individual characters if we're like specifying 0 at 0.
Yeah.
Okay, makes sense.
Exactly. Exactly. The whole difference here, though, the whole point, each one of these blocks of memory is managed separately from this block of memory, right? So they can be of variable length, right? Because if you wanted to do this with just a two-dimensional array, right? This is what you would have to do. There's no other way of doing it, right? see where I'm going with this? I might not have left myself enough room, but I did. There you go. And love is no. Right? Etc. etc. Because we're using pointers here, you know, we don't worry about those those bits don't need to exist, so they don't.
So this is essentially allows for dynamic memory allocation, if I'm not wrong.
Almost. Very, very close to the idea of dynamic memory allocation. The only difference, the thing that would make this dynamic memory allocation is like, unfortunately these character arrays are still static, right? So we have a static structure dynamically pointing to another static structure, right? Past their initialization, these things can't grow or shrink, right? So once we get to this topic, we will be able to grow and shrink arrays. Make sense?
Yes. Thank you.
Yeah, thank you. Excellent question. Excellent question. Question?
What's the advantage to using pointers, and why would we not just directly reference whatever we need?
What's the advantage to using pointers? I talked about this at length last lecture. So in some sense, I will refer you to that lecture as well, but I will go over it very briefly. Because arrays are very basic, and you can't do complicated data structures with them. In order to do better modeling of things inside, like data structures and different math models, you need pointers. Pointers are how things are being done anyways, so you should understand how they work. Yeah. But I will agree that for the purposes of setting aside a certain number of characters for taking input from standard input, something like that, you'll probably just do it with a static array and be done with it, right? But object-oriented programming is a complicated way of hiding the fact that everything's happening with pointers under the hood, right? If not for the existence of pointers, there would be no OO, right? In fact, if not for the existence of pointers, there's basically no advantage to C over assembly programming, right? So, yeah, except maybe the if statement. Anyway, I will refer you to a previous topic. So, brief note on base systems. We've been using hexadecimal quite a lot, so we should talk about it somewhat more formally. When we print a pointer, the memory address is formatted in hexadecimal. So let's just briefly review our base systems. The binary system is base 2, has digits 0 and 1. The octal system, base 8, digits 1, 2, 3, 4, 5, 6, and 7, stops at 7. So the largest octal number having 3 digits is 777, right? Just like the largest decimal digit, the largest decimal number having 3 digits is 999, right? I'm not going to insult you by teaching you the decimal system. The hexadecimal system is a little bit different. You'll notice that after 9, we represent 10, 11, 12, 13, 14, and 15 using alphabetic characters rather than numeric characters. That's why when you take a look at memory addresses which print, there's a bunch of alphabet characters in there mixed in. The difference, of course, incidentally, normally doesn't make any difference whether you use upper or lowercase letters. Normally both are exactly the same in terms of interpretation. Make sense? Hexadecimal has many, many applications. Octal, you don't see as many. The advantage, I think I've said this before, but the advantage to representations like hexadecimal and octal is that a digit will always be composed of the same number of bits, and those bits fit together perfectly, right? The decimal system has these basically 8 and 9 require 4 bits to represent. 0 through 7 require 3 bits, or less than that. So you kind of have like this leftover tail. There are a lot of unused values at the end of it if you were to just say, well, we'll just round it out to 4 bits, right? Incidentally, there is a type of encoding that you guys will be learning about later on in 2TA4 and other courses like that, called binary coded decimal, which does exactly that. It says, okay, we're going to draw 4 bits for a decimal digit, and we're not going to use the rest of those values. And you do that for like programming 7-segment displays and things like that. But in general, the computer system has to be, like a proper computer system has to be more efficient than that. You must use every value. So, the computer thinks in binary, octal, and hexadecimal. If you see anything in decimal, it's being nice and translating it for you. Make sense? Any questions? Okie dokie. I probably won't see you guys tomorrow. So have a good one. Class isn't canceled until I say it's canceled though, okay? And we'll have a makeup session on the weekend or something.